Hello students, welcome. Today from 1 topic 2 lesson 9 we want to go through the effects of heat on substances, and we are saying a substance can exist in any of the three states of matter depending on the prevailing temperatures. Remember, we have done the three states of matter. They were three in number. The first one was solid. Next we were having liquid. Then the last one, we were having vapor or gas. For example, if you are having a substance like solid ice or ice, when we heat it, we can get liquid water. If we further heat it, we are going to get water vapor or steam. If we cool steam, we'll get back to liquid water, and if we further cool the liquid ice or the liquid water, we will end up having our original ice. So that means that ice can exist in any of the three states of matter in a condition that's the prevailing temperature. So we're going to see what happens when solid ice is heated. So in this example, we are dealing with ice, but we can deal with other solid substances. For instance, naphthalene. So we're having this curve, and this is a heating curve. We have two types of curves. We're having heating curve and also cooling curve. So for us to know the heating curve and the cooling curve, what we are going to check is only the y-axis, which we usually place the temperature. So if you see the temperature increasing, that is the heating curve. If the temperature is dropping, what we are going to deal is a cooling curve. For example, if we are having a graph like this and the temperature is decreasing like that, what we are having here is called the cooling curve. Check here, the temperature initially here may be 150, so it has dropped to around 100. So that means this will be a cooling curve. What we are going to check will be the y-axis, where we usually place temperature. So if you find the temperature is dropping or it's decreasing, that means what you have is a cooling curve. So if you see the temperature is increasing, that is a heating curve. So let's go and proceed to see, explain what happens in the following regions. So we're having here regions. We're having region AB, we're having region BC, we're having region CD, and we're also having region D and E, as you can see there. So during the exam, we can be told label on the diagram the states present on the following regions. So we can be given region AB here, the state. We can be given region CD, that is here. So for us to explain that, what we are supposed to say first of all, A to B, that is the solid state. So when we are talking about B and C, we are having the solid being converted to liquid. When we are talking about C and D, the state that we have is liquid. Then when we are talking about D and E, we have liquid being converted to vapor or gas. Liquid being converted to gas, and thereafter we're having the gas state or the gaseous state. So during the exam, you can be told label on the diagram the states present on the following regions. So I have explained all those like that. The next, you can be told to explain what happens in the following regions. So we start with region AB or BC or CD or D and E. Even sometimes you can be asked to explain why the temperature remains constant in region BC and also DE. We have to explain. So all of those questions, we are going to explain it below. Okay, we start with to explain what happens in region AB. As you see, AB, the temperature starts to increase. So that's why we're saying the temperature increases steadily as the ice absorbs heat energy. So next, after that, we are saying the heat energy absorbed increases the kinetic energy of the particles. Which particles? Ice particles. And they vibrate more vigorously. So to see what we are going to have on the diagram is that the temperature is increasing steadily. Initially, it was negative 100, now it became 0. So that means the temperature has increased. We go to region BC. So before we go to BC, learners, you are supposed to know that you can explain CD on your own. Let me give you the reason. The reason is that if you know how to explain what happens in region AB, you also know what happened in region CD. As you can see, the two parts or the two regions, the temperature increases steadily. So when we are going to C and D, we will just explain C and D using A and B. So let's go to B and C. As you see, the temperature remains constant. That's why it is horizontal. So we're saying BC, the temperature remains constant. The temperature remains constant until all the ice melts. So that means now we're having where the solid is being converted to liquid. Then we're saying the heat supplied is used to weaken the forces of attraction holding the particles of ice together. Therefore, the particles move far apart and the ice changes its state from solid to liquid. That's what is going to happen in region BC. So, when you check the curve, region BC and also ED, the temperature remains constant. So that means if you know how to explain region B and C, you also know that of D and E. Okay, we are going to go to the next region, that is region C and D. We are going to explain the way we have explained in region A and B. So let's just try to see. So we are going to go to C and D. We are saying the temperature increases steadily as the liquid ice absorbs heat energy. So when we are talking about region A and B, we said as solid ice absorbs heat energy. Because in region A and B, we are having the solid phase there, or the solid state. So we're talking about solid ice. But when we come to region C and D, we're having here the liquid phase, or the liquid state. So we are seeing here the temperature increases steadily as liquid ice or liquid water absorbs heat energy. Then the heat energy absorbed increases further the kinetic energy of the particles. Which particles? The liquid particles or the liquid water particles, and they vibrate more vigorously. So remember, when you're dealing with region A and B, the temperature increases steadily as ice absorbs heat energy. So that heat energy absorbed is used to increase the kinetic energy of the particles. But when we're talking about region C and D, the heat absorbed increases further. It further increases the kinetic energy because the kinetic energy has been increased in region A and B. So in region C and D, it increases further the kinetic energy of the particles, and they vibrate more vigorously. So region E and E is the same as region B and C from a look of the curve, how the curve look like. So to explain, we are going to explain the way we have said in region B and also C. So we're going to say the temperature remains constant, that's very correct, until all the liquid water or all the liquid ice boils. So initially, we said region B and C, the temperature remains constant until all the solid ice or all the ice melts. So the reason why it was melting was that BC was the state at which solid is being converted to liquid. But when we're talking about region D and E, it is where liquids are being converted to gas or vapor. The heat supplied is used to further weaken. Remember, when we're dealing with B and C, the heat supplied is used to weaken the forces. But in D and E, we will further weaken because we have already weakened the force of attraction holding the particles of the solid state in region BC. So we're saying further weaken the force of attraction holding the particles of liquid water or liquid ice together. Therefore, the particles move far apart and the liquid water or liquid ice changes its state from liquid to gas. That's how we're going to explain. So learners, in short, what we are saying is that if you know how to explain region A and B And also B and C, you also know how to explain region C and D, and also region D and E. This, you will only change some small parts.